Today in this video lecture we will see another example. This is simply supported beam with an internal hinge at point B, and our problem statement is to find shear force diagram and bending moment diagram. Total length of this beam is 20 meter. At point A there is hinge support. Hinge support, that means vertical AY reaction and horizontal X reaction comes, this red color reactions. And at point D there is roller support. Roller support, that means vertical DY reaction comes. And at point C there is also one CY reaction. And talk about loading. At point T there is anti-clockwise 60 kilonewton meter movement, and at point F there is concentrated point load 16 kilonewton. So remember, at internal hinge location there is movement is always 0, and observe this AX, AY, CY and DX are 4 reaction here in this beam, and equal to total number of equilibrium equations are 3 plus 1. 3 is, that means summation of x equal to 0, summation of forces in x equal to 0, summation of forces in y equal to 0, and summation of moments equal to 0. That means these are 3 equilibrium equations, and plus 1, why plus 1 plus 1? Because of this internal hinge there is one equilibrium equation additionally come. So 4 equal to 4, that means this is determinant structure. So for solving this structure we need to cut this beam at this hinge location. Remember, at hinge location movement is 0, but there is shear comes. So this positive AY, this is AX, this is A, this is E, this is 16 kilonewton meter, and at point B there is shear comes, so BY. So we need to find shear at this point and movement at this point, but remember MB is equal to 0 here because this is hinge support. So for solving this reaction AY, our interest is to find this AY. So for solving this AY, first do summation of forces in y direction equal to 0. Upward is positive, downward is negative. So AY is upward, that's why positive AY. BY is downward, that's why negative BY, and equal to 0. So AY equal to BY. Now our interest is to find AY, but we don't able to find exact value of AY till now. So observe this beam and thought how to find this AY. Now take moment at point B. Moment at point B, that means summation of MB is equal to 0, clockwise positive, anti-clockwise negative. So this AY is clockwise to that point B, so positive AY into perpendicular distance between A and B is 8 meters, so 8. This 16 kilonewton is anti-clockwise, that's why minus, and 16, and equal to 0. So AY equal to 16 upon 8, it is 2 kilonewton. Put this equation AY in this equation 1, so BY is also 2 kilonewton. Now our objective is complete. We get this AY. With the help of this AY, consider this full beam, and so see, only by using AY, now unknowns are CY and DY. This AX is equal to 0 because there is no equilibrium horizontal force. That's why this AX not considered. So CY, so for CY calculation, consider this B to D beam also. Only B to D, and at point B here there is internal hinge, and here it is 16 kN downward load. So consider here BY. See, this BY is 2 kN. So here also it is 2 kN. Now summation of forces in y direction equal to 0, positive BY, positive CY, positive DY, minus 16 equal to 0. BY is 2 plus CY plus DY minus 16 equal to 0. Therefore CY plus DY equal to 14 kN. And here at B point, moment is 0. So moment at B equal to 0. Why 0? Because there is internal hinge. So again calculate summation of moment at B equal to 0. See, when we calculate summation of moment at B equal to 0, then this CY and DY unknowns. And if we calculate summation of moment at C equal to 0, then unknowns is only this dy. So take moment at C equal to 0. So for that point C, clockwise is positive 2 into 4. This 16 is also clockwise, so positive 16 into 4. This D is anti-clockwise, so minus dy into 8. So dy equal to positive 2 into 4, positive 16 into 4 minus dy into 8 equal to 0. So it is 9 kN. So AY is 2 kN and dy is 9 kN. Now calculate this CY. So consider full beam, summation of forces in y direction equal to 0. AY is 2 kN, Cy is unknown and dy is 9 kilonewton. So Cy equal to minus 11 kilonewton. So C vertical reaction are 16 and vertical forces is 16 and movement 16 kilo. So Ay is 2 kilonewton, dy is 9 kilonewton and Cy is 11. Positive 2, positive 9, 2 plus 9, 11. See, consider this upward force also 16 kilonewton. See how mistakes happens in reaction and bending moment shear force calculation. And this 16 is minus because it is downward. So this Cy equal to 2 plus 9 minus 16. So minus 5, that means here it is plus 5 kilonewton. So Ay is 2 kilonewton Ax is 0, dy is 9 kilonewton and Cy is 5 kilonewton. So calculate shear. This Ay is upward, so this 2 kilonewton. Shear force at A equal to 2 kilonewton. Now calculate shear force at E. This movement don't contribute in shear force calculation. So in between A to E there is no load. So here no load, that means here is horizontal line. See at point B there is also 2 kilonewton shear. So and between B to C there is no load. So again it is 2 kilonewton up to point C. and this Cy is vertical, positive kilonewton. So shear force just left to at point C is positive 2 and positive 5. Why positive 5? Because 5 is upward. So 2 plus 5 is 7 kilonewton. So that's why here 7 kilonewton. How this 7 kilonewton comes? Because see, this shear 2 kilonewton plus, see this reaction 2 kilonewton plus this upward reaction 5 kilonewton. 5 plus sign because of upward reaction. See, between C to D there is also no load. No load, that means horizontal line. And at dy there, so see here our one force is, this is up, and here 16 kilonewton downward force. So shear force just left to up is 7 kilonewton, because in between C to F there is no load, and shear force C just here up left, here up right. So this plus 7, downward arrow minus 16, so this is minus 9. And this goes to straight line because there is no load between F to D. And again this reaction is upward 9 kilonewton, so upward. So this is positive, negative. Shear force F just 16 kilonewton. Shear force D equal to 9 kilonewton. So this is shear force diagram. Now calculate bending moment diagram. So now BMD. Bending moment at point A equal to 0 because there is 0 pin support. Bending moment at point A equal to 0 because there is pin support. At point E there is 16 kilonewton per meter anti-clockwise, and before bending moment, see deflection shape. Deflection shape is like this, sagging. So up to point E, AY into 4, that means 2 into 4, 16 kilonewton. This AY is 2, that's 2 into 4, 8, sorry. 2 into 4, 8 kilonewton meter. So positive 8, anti-clockwise minus 16. So minus 8 here, downward, minus 8. See, at moment there is suddenly drops down in BMD. So at point B there is again 0 due to hinge support. At point B, E, A, and at point C there is again this movement goes upward, and C, shear is 0, that means bending is maximum there. So here, and point is up. So at point up, this is maximum, and again it is 0. So positive, negative, positive. And what is value of movement here? See this dy. This dy is 9 kilonewton. So, and this dy is anti-clockwise to that up point. So minus 9 into 4, it is 36. And when we count moment or shear from right hand side, then change sign. So this is positive 36 kilonewton meter. Unit is kilonewton meter. So this is SFD BMD. Maximum shear is, see this 9 kilonewton. See why at point E, at point E there is maximum shear occurs. See, load and reaction is maximum near to this up point. So that's why maximum shear happens here. And now see this similar example in StatPro calculations. So total length of this beam is 20 meter. So first node is 0, second is 12 because of this CY support. CY is at 12 meter from way. So second is 12 and third is 20. When we put node here in StatPro, see, consider second node from 0 node and third node from also 0 node. 0 to 20, 0 to 12, like this. Then add beam. Then property. See, while manually calculation, we had not considered properties of this beam like dead load or section properties like width is 230, depth is 600, that we are not considered while manually calculated. But in StatPro, we need to provide it. Why we need to provide it? Because of errorless calculation. If we don't provide here, then StatPro gives us error and don't give bending moment and shear force values. So although we have providing here section properties, we are interested to find shear force and bending moment for that loads only, 16 kilonewton moment. So StatPro gives us correct BMD for that load. We are not applying self weight or any other loading. So only we need to provide section properties 0.23, 0.45. Support. First support is pin support. So create support, fixed butt, In pin support, there is only fx and fy reaction allows. All other are releases. Fz release, mx, my, mz release. So click on that support tool and click on use cursor to assign and then assign at point A. So see this red color and this green color, two reaction comes here. And at point C there is roller and at point D there is also roller. Roller, why I consider at point C there is roller, because this is only one reaction, only FY reaction comes, all others are releases. So at support C, use cursor to assign. See, I don't able to see node here. So for that, click Shift K, first escape, first Shift K. So see, nodes are now seen. Now click support 3, click use cursor to assign on node 2 is at 12-meter distance from node 2 is at 12-meter distance from point A, and node 3 is at 20-meter distance from point A. Put your distances in StatPro from point 0. Now loading, load case details, add, consider this as a live load case 1, add, close, click on that load case 1, again add. Now our is at a distance 4 meter from a 16 kN per meter anti-clockwise. So member load, concentrated movement. See how to apply here in StatPro. See, my concentrated movement is at A there is anti-clockwise. Consider rule of thumb. Your thumb is your left hand thumb is towards Z point, and see your four fingers. Your four fingers are like that movement. So that's why I consider here DZ, GZ. Here in StatPro, anti-clockwise, that means positive. So positive 16 kilonewton meter. So it applied correctly. So click on that. Click use cursor to assign. I think we need to provide distance here also. From point A it is at a distance of 4 meters. So change, close, click on that. So use cursor to assign, click on that. See. Now next is at a distance of 4 meter from point C, 16 kilonewton concentrated point load. Member load, concentrated force, Gy minus 16. Gy is direction. See this here, this y direction. This y direction is upwards. That means we need to provide minus sign here. Minus y, downward, 16. And at the direction is y. And at a distance of 4 meter from point C. So click on that 4 meter, click on that beam, assign to selected beam, assign, and yes. Now analysis. We need to define command here also for errorless calculation. Define all, add, close, and now run analysis. So see how StatPro calculate. See 4 error comes. Why 4 error comes? What are errors? Elastic modulus not enter for solid member. Section properties not enter. Again go there. Click on section properties. See. Click on assign to view. Assign. Go to post processing. See errors are 0 now. Consider loads. Apply OK. So see, our loads are only this load case 1. So here in that load case, This section property is not considered. So now see first deflection. See this. Now see reaction. See. Why it is 0.8? That means something is wrong here. See loading again. There is 6 happen here. See, we are not providing internal hinge here at 0.8 meter. So first consider node here at a 0.8 meter and give specifications. Here in specifications beam here releases at start. So for that we are providing at starting 8 meter. So that means this 8 meter specifications beam releases start. We need to 0.4 consider beam here. Go to support, go to support 2, use cursor to assign. Yes. Now loading. It is 60 km GZ at a distance of 4 meter and assign to selected beam. Assign. Yes. Now you release to end of that 8 meter. Release is movement C. MX, MY, MZ release. And now select this also. See dimension being display dimension. So see here and display node also shift K. So see again beam again release at end again release movement end or start for that 4 meter start for that 4 meter. Add. So select assign to selected beam assign. See movements seen like this dot but here it is not applied at end. So again applied assign to selected beam assign. Yes. So now see values. Define command all add close run analysis. Again 4 error comes, 5 stochastic modulus not enter for beam 3 4. Again go to properties, select assign to view, assign yes. So go to analysis, go to post processing workflow requires report analysis. So go to analysis, run analysis and save. See how StatPro mathematically calculated, calculating section purpose, calculating section purpose, calculating section displace file, processing joint coordinate, processing member coordinate, reading member properties, finalizing reading member properties, processing support condition, read check data in load cases using 64-bit analysis using out of core basic solver, processing and setting up load vector, processing element stiffness matrix, processing triangular factorization, calculating joint displacement, finish joint displacement calculation, calculate member forces, analyze successfully completed. See that way StatPro calculate it. Creating section force BMD. Now see displacement. See at hinge how it displays. See displacement and see load also. See here it is. See. See this movement at a 4 meter. So now see BMD. See this due to this load 16 kN concentrated point load, this deflect like this, and due to this hinge this is deflect like this, hinge and movement. So annotate beam result, shear, annotate, yes. So compare this 2 kilonewton, this 7 kilonewton, this is 9 kilonewton. So yes, it is correct, accurately match with our manual calculation. Here see BMD is reverse of our BMD, manually calculated BMD shape. Why reverse? Because StatPro considers hogging as positive and hogging as positive and sagging as negative. So maximum is 36 kilonewton meter sagging. See, 36 kilonewton sagging, and here 8 kilonewton hogging. 8 kilonewton hogging. Here somewhere here it shows us that it is 4 kilonewton meter. That means here it is 4 kilonewton. See why. Today, in this video lecture, we will see shear force diagram and bending moment diagram of this beam with internal hinge at point C. Total length of this beam is 1 plus 3 plus 2, 4 plus 2, 6 meter, and throughout uniformly distributed load 15 kilonewton per meter. At point B, there is hinge support, and at point D, there is fixed support. So first, draw free body diagram of this beam. Free body diagram, that means remove support and apply reactions. This is hinge, that means two reaction here. One vertical and one horizontal. Vertical is By and horizontal is Bx. remove this fixed support also. In here, three reaction comes: one vertical, one horizontal, and one movement. dy, dx, and EMD movement. So see here, four unknowns: by, dx, dy, md. This bx is equal to 0 because bx is equal to dx. See, this bx is positive and this dx is negative, so bx is equal to dx. But we are interested in vertical reactions, so split this beam at point C at internal hinge. So one beam is like this, and other is like this. This is C point and this is also C point. This is A, this is by, this is B point, and this is UDI. 15 kilonewton per meter. This distance is 1 meter. And this distance is 3 meter. Now this CD portion is also have this 15 kilonewton per meter, and distance is 2 meter. So this horizontal reaction dx, vertical reaction dy, and movement EMD. Now use positive sign convention. So here this VC X and this is VCY. Now calculate BY from this beam. This is first beam, from this first beam, because see here three unknowns, here only one unknown. So take moment at this point. See, take moment at this point. So moment at point C, summation of moment at point C equal to 0. So By is clockwise to that point, positive By into 3. Minus 15 into 4 into 4 by 2. Equal to 0. So this by is equal to $40 kilonewton. So this by is 40 kilonewton. Now calculate this dy reaction also. For that, take summation of forces, all vertical forces equal to 0 is positive dy minus 15 into 6 equal to 0. By is 40, positive 40, positive dy minus 15 into 6 is 90 equal to 0. So dy equal to 40 minus 90, so 50 kilonewton. Now calculate shear for this beam. First judge shear force diagram. At point A, shear is 0 because it is overhang portion. At By it is upward, so this is like this. This is judgmental shear force diagram. It may be right or wrong. After correct mathematical value calculation, we will know this. Here B to C portion again UDL and C to D portion again UDL. So this is like this. Negative, positive, negative shear force diagram. For shear force, internal hinge don't have internal hinge don't effect on shear force. SFD have no effect of internal hinge. So at point A, moment is again 0, then parabolic curve, then again maximum, see like this. Hogging, hogging, then parabolic curve, then at this point at hinge moment is 0, remember, 0. This is like this. So where is shear maximum? This is 1 meter and this is total. I think as per my judgment shear is maximum at this BY point. So it's no, shear is not maximum at BY point because reaction is minimum at BY point. So let's solve shear force diagram. See, this 15 kilonewton meter is act on this 1 meter. So minus 15 into 1, that means here minus 15. This By is upward positive, so minus 15 plus 40 is 25. Again, positive 25 minus 15 into 3 plus 2, 5 is minus 50 here. So this is SFD values. Now calculate bending moment. So this 15 is minus 15 into 1 into 1 by 2. This is minus 7.5. BMD unit is kilonewton meter. And SFD unit is kilonewton. So here, see, shear is 0, that means movement is maximum. But we don't know distance from A it is. So calculate at this point, calculate at C moment. We need to calculate this EMD also moment. So for that, take moment here at this point. Minus 15 into 6 into 6 by 2 plus 40 into 5 and minus EMD equal to 0. Minus 15 into 11 plus 1, 4, 6 and positive into 6 by 2 and positive 40 into 5 is minus 70 minus MD. So MD is equal to minus 70. So here minus 70. So this MD is minus 70 kilonewton meter. And at point C, take movement at point C from right to left. So minus 70 plus 15 into 2 into 2 by 2, again minus 50 into 2 is minus 140, but when we take movement from right to left, change side, so it is plus 140. But see, this is minus 70 plus 15 into 2 into 1, and again minus 15 into 2 plus 70, where it is plus 70. See, at point C, no need to calculate moment because there it is hinge support. At hinge support, moment is always 0. So calculate movement here at a distance x. Shear is 0. So consider this as a XX section and shear is 0 there. That means this Vx is 0 there, and calculate for it. So this By upward, so positive 40, so minus 15 into, consider this distance as x, 15 into x, and this minus Vx. That means this minus Vx goes to this side, equal to 0. So is 2.66 meter. Calculate moment for 2.66 meter is positive. Wait, need to calculate it properly. AB, this is By 40 kilometer. This is Vx, and this is 15 kilonewton per meter. And this is let's solve it by similarity of triangles. See, consider this as a x, and total this distance is 5 meter. That means this is 5 minus x. So x upon 25 equal to 5 minus x upon minus 50. So minus 50 into x equal to 25 into 5 minus x. So this is minus 50 into x equal to 25 into 5 minus x. So x equal to minus 5. don't need to take minus sign, only take positive sign. So x is equal to positive 5. Only consider value. So this x is this. That means 5 plus 1, 6 meter. At a distance 6 meter from point A, at a distance 6 meter from point A, moment is maximum. So calculate for 6 meter distance, and here up to here it is 1 meter. That means from B point it is x is 5 meter. So positive 40 into 5 minus 15 into 1 into 6, 1 into 5.5. So for that C point, positive 40 into 5 minus 15 into 6 into 6 by 2, again this is 1.67 meter. So calculate moment at 2.67 meter. Positive 40 into 1.67 minus 15 into 2.67 into 2.67 by 2, it is 13.33. Now calculate at StatPro. So it matches with our manually calculated bending moment. Thank you very much.